All right, next we're going to look at what are called the medians of a triangle. All right, a median is a segment that stretches from one vertex to the midpoint of the other. And the three medians of a triangle all meet at a single point called the centroid. So we've talked about circumcenter and centroid. Circumcenter is where the perpendicular bisectors meet. Centroid is where the medians meet. There's also orthocenter and incenter. Sorry. And if you go in the classroom, there is like a write-up on that, so you can see all of them in one place. Except that it's not actually there as I say this, but I'm going to have to put it in there. I hope I remember to do it. Okay. So what we're going to do here is we're going to find the location of the centroid, the place where these three segments all meet. And there is an easy way to do this, and then there's an incredibly difficult way to do this. So I'm going to do it the incredibly difficult way first, and then we'll do it the easy way afterwards. And so the incredibly difficult way is to find the equations of these lines. We're not actually going to find the equations of all the lines. We're just going to find the equations of two of them, find where those two cross, and then check that that point is collinear with the other two endpoints. Okay, so let's start by finding the equation for, let's see, for BG, this line here. So it's going to pass through the point 7, 0 and the midpoint of side AC. So we're going to find that midpoint. And if we look here, you'll see that midpoint is 1, 2, 3, 1, 2, 3, 0.33. Now we could calculate that by just 1 plus 5 is 6 divided by 2 is 3, and 0 plus 6 divided by 2 is 3. So use the midpoint formula, but we've done that before. The slope of this segment here, so we're at 3, 3, is, let's see, 3 minus 0 over 3 minus 7, which is negative 3/4. So our equation is y equals mx minus h plus k. Y equals negative 3/4. X minus, we could pick either point. I'm going to pick this one. 7 plus 0. And I picked that one because it has 0 in it. So y equals negative 3/4 x plus 21/4. So there's our first equation. Next equation, midpoint, we're going to do from A to H. So we got to find the midpoint here, which is 1, 2, 3, 4, 5, 6. 1, 2, 3, 6, 3. And again, we could just use midpoint formula. 5 plus 7 is 12, divided by 2 is 6. 6 plus 0 is 6, divided by 2 is 3. The slope of this segment here, so this is the point 6, 3, is 3 minus 0 over 6 minus 1, or 3/5. Slope is 3/5. So our equation is y equals mx minus h plus k, 3/5. X minus, got to pick a point. I'm going to pick this one, again, because it has a 0 in it. Just makes it easier. 1 plus 0. So that's y equals 3/5 x minus 3/5. So there's our equation there. So now we need to find the point of intersection. So we just take the two x parts of the equation, set them equal to each other. We solve for x to find our x coordinate. So I have negative 3/4 x plus 21 over 4 equals 3/5 x minus 3/5. Let's see, I will add 3/4 x to each side. Where's my calculator? I feel like doing this in my head. So we've got 3abc4 plus 3abc5 is 1 7/20, which is 27/20. 27/20 x. We're going to add 3/5 to each side. So 21 not 21/4 plus 3/5 gives us 29 3/5, which is 148/5. 148/5, and we're going to divide that by 27/20. So divide by 27/20 gives us, oh boy, something went wrong. Hold on a second, I made a mistake. Okay, knew something was wrong here. This isn't 148/5. I must have punched the wrong number into the calculator. 117/20. By the way, the reason I knew that there was something terribly wrong is my x value was really big. And I know that it's going to be something 1, 2, 3, 4. Should be a little bit bigger than 4. Just it was like 29 and something. So let's try this again. We're going to divide that by 27/20 to get 4 1/3. That looks a little more reasonable. So 4 1/3 is 13/3. That's our x coordinate. Okay, 13/3. Now find our y coordinate by just plugging that in to one of these equations. Now it doesn't matter. We'll use this one up here. Minus 3/5. So we'll go 3 ABC5 times 13 ABC3 2/5 minus 3 ABC5 gives us 2. Oh, which looks about right. So our y coordinate is 2. So it's 13/3 and 2. So that's the coordinate for J. 13/3, 2. Now you want to check to see, is that going to be collinear with C and I? So if it is, then the slope of CJ will be the same as the slope of CI. So let's check. So we've got CJ is, our slope is, so we have 12 minus 6 over 13/3 minus 5. 12 minus 6 is 6, and 13/3 minus 5, 13 ABC thirds minus 5 is negative 2/3. And actually, let's simplify that. 6 divided by 2/3 is 9. But it's going to be negative 9. Okay. And then I is the point 1, 2, 3, 0. And that's just the midpoint of AB. So, let's see. Uh-oh. Wait a minute. Something's wrong with that calculation too. Hold on. Oh, I just realized that's not 12. That's comma 2. So 2 minus 6 is negative 4. And negative 4 divided by 2/3 is negative, oh, it's going to be 6 though, positive 6. Positive 6. Now let's try this one. Let's see. Oh, this isn't a 3. This is a 4. Man, I'm making all sorts of mistakes. 1, 2, 3, 4. Okay. So, our slope here is 0 minus 6 over 4 minus 5, which is negative 6 over negative 1, or just positive 6. So the two slopes do turn out to be the same. So it is collinear. I would like to point out, you see I've made like a crap ton of mistakes here, but I've caught every single one. I've caught it fairly quickly, largely because, for example, I knew these should turn out to be the same, and all of a sudden I'm like, oh, that's not going to be 9. What's wrong? Then I realized I copied something down wrong. I've relied on my diagram as kind of a visual aid. It doesn't tell me exactly, but it did tell me that the x-coordinate for that point couldn't be like 29 point something, right? It had to be something much smaller. So all along the way, like looking at what I'm doing and kind of keeping track, having an idea of where things are going to turn out, and especially relying on the diagram as sort of a visual aid that helps a lot. So in fact, these are collinear because those two slopes do turn out to be the same. Now, after all that work to find that point of intersection, there is actually a super easy way to do this. All I do is I go x sub 1, x sub 2, x sub 3 over 3, y sub 1, y sub 2, y sub 3 over 3. I just average together the 3x coordinates and average together the 3y coordinates. So I've got 1, 5, and 7. 1 plus 5 plus 7 over 3. 0 plus 6 plus 0 over 3. 1 and 5 is 6, and 7 is 13 over 3. And 6 over 3 is 2. All right, and the reason for that is that the centroid is kind of it's the balancing point of the whole entire triangle, and so its coordinates are the average x coordinate and the average y coordinate. Okay. There you go, much easier way.